Android programmers. In this video, we're continuing on from the last video where we're specifically going to extend our vanilla Android Beacon app to make use of Oracle Mobile Cloud Services Location-Based Services API. G'day, I'm Chris Muir from the Oracle Mobile Platform team. So, in the previous video, we explored how to write a simple Android application to detect a beacon using the third-party Android Beacon library. In that video, we hard-coded the beacon identifiers for the UUID plus major and minor values. Now what we're going to do in this video is we're going to explore how MCS can make the app more interactive by removing the hard coding and relying on MCS location-based services to provide these values. So, imagine we're opening, say, a great new shop called Chris's Emporium of Knickknacks, and we'll be creating a mobile app for our customers. Now our esteemed CEO, who is me, wants us to set up a beacon at the front of the store, such that when a customer with our app installed on the phone approaches the beacon, we'll send the customer a personalized message offering them a bargain on knickknacks to entice them into our store. So to support this scenario, in MCS we'll create a place, Chris's Emporium, and we'll define an alt beacon with the following UUID, major and minor values. Then, returning to Android Studio and our sample beacon application from the previous video, you'll note we've already hard-coded the UUID, major and minor values. Now, we will derive these values from MCS based on the data we just created to remove the hard coding, which will also avoid any issues of having to change them in the app source code and redistributing the app. Now, something else we want to do as well is when we detect the actual beacon, the current message is currently hard-coded as well, so we'd like to retrieve that message from MCS too. So to solve these problems, we're going to use the MCS Android SDK. Now first, you need to add the MCS Android SDK to your application. Now we've already covered that in earlier videos, so we won't cover that again here. Then in code, we need to access the MCS mobile backend and authenticate the user. Again, we've covered that in previous videos, so to keep things simple for this demo, I'll authenticate anonymously. From there, we want to remotely query MCS's location-based services REST APIs. Now, if we look to the MCS user interface, we can see that it supports a number of different endpoints, such as querying places, assets, and devices. However, thanks to the client SDK, we don't need to make raw REST calls from the mobile device. Rather, we can use the modules provided by the SDK to do the bulk of the work for us. So here I'm instantiating a location place query object, which will allow me to remotely query places from the REST endpoint places query. Then I'll define the query criteria. As I'm interested in only one place, essentially Chris's Emporium, I query based on this name, though I can also query by description, label, or places nearest to the latitude and longitude coordinate, or in a geofence boundary as example. The query by name is wildcarded, so I need to ensure I don't get any other Chris's Emporiums with a suffix returned. So I have to limit the result to 1 and sort by name ascending. Next, we call the async method execute that will make the remote call to the REST API places query. If successful, a result will be returned, and if not, an error will be returned which we must handle. Assuming all things go well, the result contains as a property an items array of location places. Again, for this demo, I know only one object will return, so I just fetch the index 0 of the array. Next, as our goal is to retrieve the device UUID, major and minor values for this associated place, I call the async function fetchDevices on the location place object. This will get an array of location devices as successful, and again, as I know we only have one device, I can safely extract the UUID, major and minor values, and create a new instance of region, which we can turn to our original method. So with this in place, we are now dynamically deriving the UUID, major and minor beacon identifiers from MCS. As we mentioned, our other goal is to remove the hard-coded message for when the specific beacon is detected. instead retrieving a custom message from MCS, which we can dynamically change without needing to redeploy the app. Firstly, in MCS for the beacon, let's define a custom attribute, beacon message, with a value welcome to Chris's Emporium. Returning to our code, when we retrieve the beacon identifiers from MCS, we can also add code to retrieve the custom attribute. And having done all this, now in returning to our demo application, as I'm doing here, I'm projecting my Nexus 7, my Android tablet, onto the screen. I'm bringing a alt beacon up to the device, and you can see the result of the changes that the code we've made as it detects the beacon. As you can see, working with the MCS location data is a doddle when you use the MCS Android SDK. And it really isn't hard at all to remove all the hard coding from your app to make your app much more flexible for your business needs. Thanks for watching. Catch you in the next video soon.